Hey guys, welcome. Yeah, so example 6 here, and as per promise, we have a repeated quadratic denominator this time, and since we have x squared plus 3 squared, and that's repeated twice, x squared plus 3 times x squared plus 3, what we have to do is just pay attention to that number right there, which tells us how many rational expressions we're going to have on the right side of that equal sign, and we're going to have two. One of them is just going to be x squared plus 3, so the repeated quadratic factor to the first power, if you want. makes you feel better if you write that, but better that you don't. Just leave it like that. And then this next guy is going to be, and I keep doing this because I need space, so I should, anyway, I should know ahead of time that I need that. But anyway, this here is going to be x squared plus 3 to the second power. Good. Now we put a plus sign here, and the numerator here, since this is a quadratic denominator, is going to assume linear form ax plus b, and the numerator here is also going to assume linear form, and so let's write cx plus d, although you might have suspected that this numerator needs to be a cubic, since technically our denominator here is a quartic. It's a fourth degree polynomial if you expanded x squared plus 3 all squared, right? But yeah, we take exception to the rule that if we have a quartic denominator, our numerator needs to assume cubic form, because here this quartic came about through a repeated quadratic factor. Yeah? Okay, cool. Alright, so if you watched example 5, you see that this is symmetric to the repeated linear denominator situation. Alright. That's too close for comfort with the title, so lower it a little. But now what we have to do is get common denominators here on the right side. This plus sign, it's probably gonna get in the way, but not on the right side, so slide it and multiply here by x squared plus 3, which means that I have to multiply here also by x squared plus 3. Okay, so now we have common denominators, and so we could just write one denominator, and that one denominator is x squared plus 3 all squared, right? This here is it, and this here is it, and this here is it. And now this here, which is equal to this, is going to in turn equal to this, and notice that the denominators are already equal, and so what we require is that this numerator be equal to what I'm about to write here in this numerator, and what I'm about to write is more like what I have to write, right? And what I have to write is this, ax plus b times x squared plus 3, and then plus cx plus d. Now, since this here will need to equal this, and the denominators are already equal, what we're going to say is that we need x cubed plus 2x squared, the numerator here, to equal the numerator here, and that is to equal ax plus b times x squared plus 3. Need space. Okay. And then what? And then plus cx plus d, right? Okay, cool. So we don't really need this anymore. Don't need you anymore. So there that is. Now let's simplify this here. Although we said in earlier examples that we have two options here, where one of the options is plugging in specific values of x and then creating equations. Notice that here we'd have to pick 4 x values and and then like solve a system of 4 equations and the 4 unknowns a, b, c, and d. That's a lot of work. It's better if we just compare coefficients of the polynomial on the left and the polynomial on the right, and then get our equations that way. So let's write this polynomial to the left of the equal sign the way it would appear in full, and that is with a 0x and then plus 0, and then on the right side, if we first FOIL here, we'll have ax cubed and then plus 3ax and then plus bx squared and then plus 3b, oh no, so plus 3b and then plus cx plus d. And if we like rearrange the terms and group them and make them easy to compare to this left side, then we'd write ax squared plus, sorry, it's not ax squared, it's ax cubed plus bx squared, and then it's plus, there are two x terms, this guy and that guy, and we can lump them and write 3a plus cx, and then plus how many constant terms are there? Just two. This guy, and that's 3b plus d, right? 3b 3b plus d. Alright, now this was an intermediate step, so we could do without it, and so let's get rid of it. So there that is, and now this here slid up will get us the equations we need to solve for a, b, c, and d. And we don't need this here, but need the space. And so let's write our equations, right? And our equations are going to say, what are they going to say? They're going to say that 1 here is equal to a. That's good. Right away we know a is equal to 1. Okay, and this here is equal to b. Nice, that's convenient too. B is equal to 2. Is c 3? Okay, no, not that lucky. Now, but not too bad, because we know that 3a plus c has to equal 0. We also know a is 1, so that just says 3 plus c has to equal 0, which means that c is equal to -3. Not a lot of effort. And then we know that 3b plus d has to equal 0 there, right? So 0 equals 3b plus d, and we'd known earlier that b is 2. So 0 has to equal 6 plus d, and therefore d is equal to -6. Got everything we need. So get rid of all of this and do what? Do this. Take this guy, set it there. Take this guy. Okay, you get it. I don't have to say that. Okay. And then finalement, right there. And we're done, right? We were done, right? As soon as we solved for these, because all I have left to do is now claim that this is equal to, it's equal to ax plus b, and so a is 1 and b is 2, so x plus 2 divided by x squared plus 3, and then plus cx plus d, and so that's negative 3x, and then d is -6, so plus a -6, which is -6, and then all of this divided by x squared plus 3, x squared plus 3 all squared. Now if you so wanted, you could have written this instead, which is perhaps a bit nicer, which is put a minus sign here, and then put a 3 here, and then it's going to be x plus 2, and then divided by x squared plus 3 O squared. That's it for example 6, and we're done. And example 7, our final example, is to come. Okay, bye, take care.